Okay, so I've fixed the typo. So what we have here is a series of just 3 integers, 0, 1, 2, and the indexes are A, B, and C. So if we slice from x from position 0 to position 2, we get the first we get position 0, position 1, but not position 2. These are the indexes, the names of the columns are A and B. In fact, I should probably change this to I'm just going to change it so it's not at all redundant with what we have. So the point to make here is that when we're using positional slicing, we don't get the second. We get the start point up to, but not including the end point. Whereas if we use label-based indexing, we get the start and the end. And this, the idea behind this, the reason that it has this behavior is that it's a little more intuitive. You say you're actually giving the label that you want, and so it's going to give you both values. But the point, where this comes in handy is that these date-time indexes are effectively labels and not positions. So we say we're going to get from May 1st to May 31st. We want all those dates, right? We don't want to have to say I want from May 1st to June 1st, but you're only going to give me May. It's a design decision of the Pandas package, but it ends up making a little more sense. So I'll show you some examples here. So first we're going to show that you can pass in strings and it will infer that this is January 31st, even though it's not a normal date-time object, or we can specify like this. But if we're going to do a slice, we can see that we're going from October 31st to December 31st. We're getting all three of those. We're getting all three of those months represented. And in this case, it recognizes that December 30th is actually the last day in our data set, so it will give us that. But we could have put December 30th as well, and it would still work. If you want to get all the data points in a given year, you can specify just the year, and it will infer that. Or you can specify year and a month, and it will give you the date, the values corresponding to that month. So we can make this, make an array of random numbers with a certain column name A, and convert this to and adding an index with the date range from January 1st, 2013, and then every hour up till the end. And so if we type 2013, we'll get all of the values, or we can just get the values from January to February. So you can see that we get all the way to the end of February. And even if we do specify the date, we still get all the way to the end of that date. So in this case, we're going to stop at the beginning of that last day, February 28th, which would be midnight. And in that case, we'll get only that first time on that last day. just to hammer this home, if we pass 1230 as our last time point, that's going to be the last time point that we get. And if you want a single row, you can use the location, this label-based indexing to get just a single row. So here we get we will get all of the, this is just a same guy that we're getting from the start to the end of this time span.
I have a question.
Yeah.
When we did the, like the pretty large set of DF, when we first looked at DFT,
Yeah.
above, it says that there's 100,000 rows. Is that just because that's all it's telling me that it has? Because I would think more than, so here it's 83,000 rows for just 2 months or whatever, January, February, but here, further up, it says there, 100,000 rows. A little further down.
Mm-hmm.
Yeah, there.
Yeah, it goes to the 11th of March. So
Is it lying to me that it's 100,000 rows? Is it just truncating there? Or?
no, it should have, this should have 100,000 rows.
It's supposed to?
Yeah. I mean, we can do.
Did we specify we only wanted 100,000?
Yeah. So we said we have a random number.
Okay.
So this is a 100,000 times by 1, and then
I missed that.
yeah. So we can say we can truncate. We can basically do the same thing as slicing, but we're going back to this TS object, and we can provide a before and an after to get this slice here. And we can get just, here we're using a fancy indexing method, so we're passing a list to get just these positions 0, 2, and 6 from the index, or from the series, and then we're looking at the index of that. And you can see that, and now we've lost the frequency information because we no longer have regularly spaced data. So there's some other date time properties that we can access. So year, month, day, hour, these are all things that we can see. We'll see these in a minute. So for example, here's TS again, and if we do TS.index, which is this part here on the left, and then .month, this will give us the months of those indexes. So all these timestamp objects or datetime objects have these properties associated with them. Another feature that we have is offsets. So this is a way that we can advance forward or backward. So for example, we make this datetime object D. We can convert that to a timestamp. And we can then add to that an offset of 2 months and 1 day. So you can see now we've advanced this 2 months and 1 day, but it's the time is still the same. So you can add and subtract. You can multiply by an integer to increment by that number of times, and you can have this roll forward and roll back functionality as well. So, for example, we can take a given date and subtract 5 business days from it. So if our date is the 27th, that's today, right? Today's Tuesday. If we go 5 business days backward, that would be 1 week ago, so that's the 20th. And if we wanted to go forward 1 business month end, we can go to the end of this month, which would be tomorrow. That's the last business day of the month. And if we can also store the offset as an object, as an offset object, and then apply these roll forward and roll back methods on the date. So it's kind of inverting the way we think about this, but it works the same way. So we get roll forward, roll back. So we can roll from 9 a.m. today. We can roll forward a day or roll back a day. Roll forward a month or roll back a month using the business month end. So if you were just not wanting to do business days, you just wanted regular days, you could do month end instead of B month end. We can also apply, so if we set the day as our offset object and then apply that on a timestamp. So this is January 1st, we get January 2nd. If we set normalize equals true, it will convert that to, it will reset the time to midnight instead of 9 a.m. We can also roll forward an hour or offset an hour, and this will, in this case, it will. It's rolling from 22 or 10 p.m. to, sorry. Yeah, so in this case it's rolling from 10 p.m. to 11 p.m., but normalized is true, so it's going back to midnight, normalizing it's back. But now if we do that on 11 p.m., it now goes to the next day, so you can see why it switches to the next day.